Okay, so hello students, welcome to this video. So in this video, we will solve a problem from CSIR NET June 2024 exam, and the question is from electrostats. Okay, so the question is the region y greater than 0 has a constant electrostatic potential V1 and y less than 0 has a constant electrostatic potential V2 which is not equal to V1. Then a charged particle with momentum P1 is incident at an angle θ1 on the interface of two regions. If the particle has momentum P2 in the region y less than 0, then the angle θ2 is given by, means we have to find out the relationship between θ1 and θ2 in terms of the given quantities, that is the momentum P1 and P2 in two regions. Okay, so let's solve this question. Now you can see the potential difference is along y direction, means V1 here and V2 here. So there is a potential difference along y direction, and hence we can say there will be the electric field along the y direction, and hence the resultant force will be along y direction. Net external force will be along y direction, means Fy will be something. It will not simply equal to 0. 0 के बराबर तो नहीं होगा. But in the x direction, if you see, in region number 1, in region number 2, in x direction, there will no change in the potential. So there is no potential difference, no field, and hence external force is also 0, you can say. So Fx is equal to 0. And this is the most crucial point of this question, that force, external force in the x direction is 0, and if net force in a particular direction is 0, then we can apply the conservation of linear momentum. So this is the point कि कहाँ हमें conservation of linear momentum यहाँ पे apply करना है. From this information we can calculate. Now see, if this is P1 and this is P2, the momentum in region number 1, region number 2, this is θ1. So this will be P1 sin θ1 and this will be P2 sin θ2. P1 sin θ1 and P2 sin θ2. So now let's solve it further. So Fx, since Fx is equal to 0, P1 sin θ1 is equal to P2 sin θ2. We have to calculate the value of θ2. So then we can calculate sin θ2, which is equal to P1 by P2 sin of θ1. P1 by P2 sin of θ1. So if we calculate θ2 from here, so you can write down that θ2 is equal to sine inverse P1 by P2 sine of θ1. So this is option number 4. Okay, sine inverse P1 by P2 sine θ1. So this is how we can solve this question. The question was easy, but the important point we have to find out the relationship between this P1 and P2 in terms of θ1 and θ2, and that comes from the principle of linear momentum, and that comes from the concept that net force in the x direction is 0. However, in the y direction there will be some force because of the potential difference. Okay, so option 4 is the correct answer. Okay, bye bye.